Hi guys, here with a team of 4 members are here to explain you about the Java threads. Here are the contents that we are going to discuss in this presentation. So firstly we'll start with the introduction and then the states of the thread and then creating a thread with some examples and multi-threading with a supporting example and then the concepts of thread scheduling and thread synchronization and finally the pros and cons. So starting with the introduction. So what is a thread? A thread is a single sequence of execution within a program. So that means it has only one single sequential flow of control. So say at some instant there is at most only one instruction that is being executed in the program. And now we'll see something about multi-threading. Java Virtual Machine allows an application to have multiple programs of execution running concurrently. So multi-threading is a concept in which multiple threads work together to accomplish a common goal. So we will explain this with some supporting example. So let us consider a video game. So here each task is assigned with a thread. See, yeah, like graphics for one thread, user interaction for one thread, and networking for another thread. So here all the threads work together to accomplish a common goal, that is a successful video game to the user. So here at some instance there may exist multiple instructions or execution points that are being executed in the program. So that is allowed in the multi-threading.
Coming to the methods of threads, we have few methods called start, run, wait, stop, suspend, join, and set priority. Coming to the start function, it creates a new thread and makes it runnable. This method can be called only once. The next is the run method. The new thread begins its life inside this method. Wait. Wait function is assigned to make the currently executed thread to wait for the other thread to get into its process. Notify function is used to notify the next priority thread that it can enter into the run method. Stop kills a specific thread. Suspend. Unlike stop, we can suspend the thread temporarily and can resume the thread whenever we want. Join. When a current thread uses join function, it waits for the other higher priority thread to complete its execution. The last one is the set priority. Each thread will be assigned a priority 0 to 10 in number. If the thread is not assigned any priority, by default it's taken to be 5. The states of Java. There are 4 separate states in Java threads. They are new, runnable, blocked, and dead. Coming to the new state is the one in which a thread is created and is about to enter into the main memory. After entering into the main memory, memory space is allocated. The next state is the runnable. This is the state in which the thread is under the control of the CPU. That is, when the thread is executing the user-defined logic of the Java program with the help of CPU, it is in the runnable state. The next state is blocked. As explained earlier, when we use wait function or the join function, the specific thread waits and does not run. This state is called block state. The last state is the dead state. A dead state is in the state where the thread has finished or been stopped. For example, when we use a stop function, the thread gets killed and does not run. This is the diagrammatic representation of the states of Java threads. As soon as we start, a new thread is created and the state of this thread is new. When the thread is ready for execution, it is said to be in the runnable state. When the execution of the present thread is over, the run method ends and this state is known as the dead state. During the run method, for process synchronization, we use wait method, or a current thread may wait for its input-output requests. During this stage, the thread swaps to the block state from the runnable state. Once the input-output request is over, or the specified wait time is over, or in case of utilization of wait function, when we use the resume function, the thread transfers again to the run method and hence transfers its state to the runnable state.
And now we'll see how to create a thread. There are two ways to create a thread of execution, and firstly extracting the thread class and then implementing the runnable interface. Extending the thread class uses java.language package, and implementing the runnable interface uses interface runnable package. In both ways the thread runs at the run command, so in both ways the thread command should be used. And so we'll see the first example, the first method. uh, Using the first method, the flow of control can be created in three ways. So here, like thread t1 is equal to new thread, here we are using the new operator to create a new thread. And then the second one is by using a factory method as shown here. And then finally by using object of subclass like this. So here T1 is an object of th1 class, and th1 is the subclass of thread class. So finally T1 is an indirect object of java.language package. So thread actually starts running at the run command, and it finishes when the run method finishes. So to execute this thread, we have to invoke a start command to get the thread ready to run. And now we'll discuss this with a programming example. And here we go. And this program is a thread. uh, the desired output for this thread string is, for this thread is a string, and it is assigned here. And we invoke the run command to get the thread running. And from here the thread execution starts. The runtime output of the thread is assigned a string as to say. Here the sleep command is used to make the thread to be inactive or to sleep for 1000 milliseconds. We gave try and catch commands here to catch any possible exceptions so that we can rectify them later. So this is all about the thread program, and now we will see what's the main program. Yeah, here is the main program. Um, Say the desired output is hello there. So to make it possible, we have to call the thread twice so that we get those two strings like hello and there. So here um, we create two outputs in the form of two threads, and here is hello and there. So we will call the thread one here like th1 start, and at the start point the this will start a new thread which begins it executing by calling th1 dot run. And like here it will get the hello point, and then here again the there will come. So the desired output hello there will be obtained. And here the main thread is not any other component in the program, it is just another thread which always happens to start first. And the main thread should end before all the other threads gets over. And any thread can spawn more threads, which means inheritance is possible in threads, so that like we can derive subclasses from classes, we can derive some more threads from a thread.
Yeah, now coming to the method creating threads method 2, the implementing runnable interface. Actually, it is the same of the first method. Like the first method, it should define the run method as that where the thread execution begins. And compared to method 1, we set up the thread in a slightly different manner here. The second method, shit, array. Coming to the run method in creating threads method 2, actually it is the same as the first method. Like first method, it should define the run method as that's where the thread execution begins. The run method of that class defined with null body and run method of runnable interference belongs to abstract. Industry is highly recommended to override abstract run method of runnable interface, but null body run method of thread class. Here is the creating thread example 2, the program. The program is same as the previous example 1 except for the class output that implement runnable. Here is the example for creating thread. The string assignment and the desired outputs are all the same as previous example. So this is the thread example of second example. Now let's go to the main program. In method 2, the main class won't invoke the thread properties by default. So we have to create a thread for each string output and then we have to call each thread for execution. So here are the two strings hello and there, which when called can give us the desired output. So here we create two threads for two strings, and here we call each thread for execution. The main class is bit more complex than the extending thread method. Apart from that, everything is identical to the first method. Runnable method is more advantageous than extending thread method. The extending thread class allows to extend only one class, which is a disadvantage over runnable method. Implementing runnable allows class to extend something else. Now we will discuss multithreading with supporting examples. Here we present a simple and basic example of multithreading, where we create three different classes with iteration loops. Once the iteration of the thread completes, then the class should exit and the iteration of the next thread begins. Here is the main program, where we call each thread separately of their execution, and the output is shown here. As we see here, once the entire iteration is complete, the thread is exception class has, and so on. Now comes to the Java thread scheduling. If there are more than one thread in a program, the thread execution is done according to their priority. The priority can be adjusted subsequently using the setPriority method. The priority of a thread may be obtained by getting priority method. Priority are assigned 1 to 10 in number. Those are the minimum priority is 1 and the maximum is 10. If a thread is not assigned to any priority, then by default it assumes to be normal priority. Here is the normal priority is 5. According to the priority numbers, the higher priority thread runs first. The low priority threads shall wait. The yield function. The current running thread gives a processor completely or for quite some time to another equal priority thread. If there are no threads of equal priority exits, the current thread runs again. Using sleep, we have the advantage to stop executing the current thread of giving chance for the lower priority threads to run. Here we set the amount of time until which the current running thread should allow the lower priority thread to run. In general, the time is set in milliseconds.
We discuss about the thread synchronization. To eliminate inconsistent results in the thread synchronization, we have to use when we start with two or more multiple threads within a program, there may be a situation when multiple threads try to access the same resource, and finally they can produce the inconsistent results due to concurrency issue. For example, if multiple threads try to write within the same file, then they may be corrupt the data because one of the threads can overwrite the data, or while one thread is opening the same file at the same time, another thread might be closing the same file, and so there is no need to synchronize the action of multiple threads and make sure that only one thread can access the resource at a given point of time. This implementing using a concept called monitors. Each object in Java is associated with a monitor, which a thread can lock or unlock. Only one thread at a time may hold a lock on a monitor. Java program language provides a very handy way to create threads and synchronizing their tasks by using synchronized blocks. You keep shared resources within this block following the general form of the synchronization statement, that is synchronized object identifier, which in the blocks of data we use the access shared variables and other shared resources. Here the object identifier is a reference to an object whose lock associate with the monitor, then the synchronized statement represents. Now we are going to see two examples. They will be print a counter using two different threads. When threads are not synchronized, they will print counter value which is not in the synchronized. But when we print counter by printing inside the synchronized block, then it prints counter very much in the sequence for the both threads. There are two synchronization techniques, which are synchronized methods and synchronized blocks. Coming to the synchronized methods, there are also two. There are synchronized instance methods and synchronized static methods. Synchronized instance methods. In an ordinary instance method accessed by multiple threads, then an ordinary instance method generates inconsistent results. To avoid these inconsistent results, the ordinary instance method definition must be preceded by a keyword synchronized. Coming to the syntax of the instance method, there is a synchronized return type method name displays in this one. Coming to the example, when the thread is executing the above synchronized instance method called the deposit, then an object of account class will be locked. Object of account class will be locked so that the other threads cannot be entered in the deposit method until the current thread completes its execution. In general, as long as one of the thread is executing any synchronized instance method, then the corresponding class object will be locked. Coming to the second method, synchronized static methods. If any ordinary static method accessed by multiple threads, then there is the possibility of getting inconsistent results. To avoid these inconsistent results, we make the ordinary static methods by definition as synchronized. The difference between is we use the instance method, we use a keyword, but here we use the definition as synchronization static method. Coming to the syntax, we use the class account, that is the static. For example, here as long as the thread is executing the above synchronized static deposit method, then the Java virtual machine locks account class. In general, when the thread is executing synchronized static method, then the corresponding class will be locked. Coming to the synchronized blocks. Synchronized block is an alternative thread synchronization technique for synchronized methods to achieve consistent results. Whenever we are inheriting non-synchronized instance methods into the derived class, and if the inherited non-synchronized instance method accessed by multiple threads, then we get inconsistent results. To avoid these inconsistent results, the Java class programmer, we are attempting to write synchronized keyword before the inherited non-synchronized instance methods, which isn't possible because as a derived class programmer, we can't change the prototype of base class or base inheritance methods. So we are unable to eliminate inconsistent results in this context by using synchronized methods. Hence, in any circumstance, in order to get a consistent results, we need to apply the consistency of synchronized blocks. Here the syntax follows the synchronized class object, and which blocks will be always written in the context of instance methods but not in the static methods, because the methods are always recommended to override but not recommended to override the static methods. For example, consider the Java program. The package is application public interface account. We use the void. The void deposit is a non-synchronized instance method. In this, the deposit method is a inherited non-synchronized instance method, and all this is a synchronized block.
Here is the example of threading and synchronization in Java. We will discuss this concept with an example of banking. Assume a scenario where a customer is trying to transfer funds from his account to some other account. We give a Boolean function here which will decide whether the transaction can be done or not. If there are not enough funds in the account, it returns false. If the funds are good enough, then the Boolean function returns true and the transaction is approved. If the funds the customer is going to transfer is a negative number, then it returns false and the transaction is denied. Here, we defined all the three scenarios with three different threads using synchronization concepts. Coming to the pros of Java threads, we will assign each task with a thread so that execution will get easier. A thread runs only when we need it, so there won't be any unwanted execution of any part of the program, which ultimately increases the performance. Multiple threads can share the same resource or various resources. That is, there is flexibility. If a system has multiple processes, threads can utilize multiple processes. Here are the cons of Java threads. As multiple threads can use same resource, there is a possibility for inconsistent results and we see a deadlock condition. Switching between threads should be accurately programmed, else overhead among the switching of threads will occur. This is all about our presentation. Thank you.